Hi everybody! Today I want to talk about PyTest's built-in cache fixture, which provides a simple key value store that survives across test cases and also across test runs. This means that you can store stuff inside of the cache and access it again, either in a later test case in the current test run, or more commonly in a subsequent test run. One of the reasons why you should care about the cache fixture in PyTest is that it is the basis of several other PyTest plugins that build on top of it and use it to implement their own functionality. Today we will examine how the cache fixture works, how you can use it inside of your test cases, and more importantly, we will take a look at some of the plugins that depend on it. By the end of this video, you will hopefully agree with me that direct usage of the cache fixture inside of your tests is a bad idea in almost all cases, but using the plugins that depend on it and build on top of it can make a lot of sense and improve your development workflow. After all, using it directly can make your tests order dependent and thereby introduce subtle bugs. It goes without saying that order dependence of your test cases is a bad practice, and depending on who you ask, it may even be considered a bug by itself. So let's get into it. To demonstrate how the cache fixture itself works, I'm starting off with a completely empty directory, and the first thing I want to show to you is the documentation for the two -- cache options. The first one shows whatever is currently stored inside your cache and optionally takes a pattern to filter the contents. The second one clears your cache and then proceeds to run your test suite from a blank slate. If you run PyTest now with the cache show option, it tells you that your cache is currently empty, but this will change when we start playing with the cache. So now I'm creating a file for our first test case, which will take the cache fixture as an argument. I'm also adding a type annotation for the cache fixture, and to do so I have to import the PyTest module to have access to the cache class. The cache object that received as an argument and that is the fixture has a lot of methods, but only get and set are relevant for us. Get takes two arguments, the first of which is the key that you want to read from the cache, and the second is a default value that is returned if the given key does not exist in the cache. The set method also takes two arguments, namely the key and value that should be written into the cache. Next, I'm attempting to get the value of a given key from the cache and print it to std out. As you saw before, the get method also requires a default value, so I'm passing this in as well. Note that I'm prefixing the key with my app because this is the recommended best practice to ensure that there can't be any collisions with other code that may also set the same key. If you now run the test and pass in the -s option to disable capturing of standard output, then you see that it prints the default value that I just gave it, and the reason for that is of course that the key that I requested does not exist. If I now go back into the code and set my key to some value, and then run the test again, then you'll see that it no longer prints the default value because the key in the cache is now present. If I now add a second test case that's in order after the first test case, and inside of the second test case I also get and print the same key from the cache, then you'll see that it prints the key that I set inside of the first test case 2 times, but it never prints the default value, and the reason for that is of course that the cache persists across test cases. When I now go back to the first test case and set the key to a different value and afterwards get and print it again, then when I run the test case you see that it first prints the first value and afterwards it prints the second value that I set. And this demonstrates that keys, if they already exist in the cache, are simply overwritten, and also it demonstrates that whatever is the latest value of the key that you set inside of a test case, this is what carries through to the next test case in the sequence. So far everything may seem fine because the tests both succeed even if I clear the cache, assuming I spell the option correctly. But in reality we have already introduced a subtle problem and made our two tests order dependent. I can easily prove this by changing the order of the two test cases so that the second test case is executed before the first test case, and then I run the whole test suite again, and as you'll see, we get a different output. This is not yet so bad that it would make the test run fail, because the values that we get from the cache don't influence any assertions, but it's easy to imagine that this could be the case. Anyways, before we move on to other topics, I want to quickly show to you how the cache stores its keys and values. This is really quite easy to understand because it maps one-to-one to the file system. namely PyTest is creating directories and files that map to the keys, and inside of the files it just stores the values that you pass to it. The first plugin that I want to demonstrate to you is the new first plugin, and this has the purpose of executing newly added test cases before existing test cases. To showcase how this plugin works, I need a new test suite with a single test case at first, and I'm immediately executing it with the -RA option, which tells PyTest to give us more detailed output. When I then go back into the code and add a second test case number 2, and then execute the test suite again in the same way, you see that it executes test case number 1 first and test case number 2 second, and that's because that's the order in which the test cases appear in the file. I then go back into the code and add a new test case number 3, and when I execute the test suite now again, I add the new first option, and this has the result that it executes test case number 3 first, because this is the only test case that has not been seen before in a previous test run. However, if I then execute the same command another time, again with the new first option, then it goes back to the regular order, because at this point the test case number 3 is no longer new, because it has been seen in a previous test run. This feature is especially useful in combination with the exit first option, which means that PyTest will exit as soon as the first test case has failed. Imagine you are working on a project and you are adding a new test case. The newest test case is obviously the most likely to fail, because it may not even be implemented if you are doing test-driven development. In this case, it does make sense to execute the newest test case first, because it means that you have a shorter feedback cycle. The second plugin that I want to demonstrate is the failed first plugin, and this has the purpose of executing test cases that failed in the previous test run before all of the other test cases that succeeded in the previous test run. To showcase how this works, I'm creating a new Python file with 3 test cases, tests number 1, 2 and 3, and I'm forcing the second test case, the one in the middle, to fail by adding an assert false. When I then run the test suite, even if I run it multiple times in a row, you'll see that it executes the test cases in the order in which they are defined. In other words, always the second one, the one in the middle, is the failing one. When I then add the failed first option, the order of test execution changes, because PyTest takes all of the failures of the previous test run and executes these test cases first. This behavior is again especially useful in combination with the exit first option, so that PyTest exits as soon as the first failure happens. Internally, PyTest is using the test fixture to store the list of failed test cases so that it knows about them in the next test run. If I then go back into the code and fix test number 2 so that it no longer fails, and then I execute the test suite again, then you'll see that it still executes test number 2 in first place, because on the previous test run we still had a failure, namely test number 2, but if I then execute it yet another time, then it will go back to the regular order, because the previous test case had no failures. The third plugin that I want to present today is the last fail plugin, and this is really quite easy to understand, because it simply filters the test suite so that it only runs the test cases that failed in the previous test run. I have already prepared a small test suite with 3 test cases and 1 failure, and if I run this, you see 2 pass tests and 1 failed test. If I now run it again with the last failed option, you see that it only runs the failing test, but no longer the 2 tests that passed before. If I then go into the code and fix the failing test case, and then I run it again, it's still doing the same thing. It runs the test case that used to fail before. But if I run the command then yet another time, then it's executing again the whole test suite, and this is the default behavior of last failed, which can be changed with the last failed no failures option. And this option can be set either to all, which is the behavior that we just saw, meaning run the whole test suite, or it can be set to none, which means don't run anything if there are no previous failures and just exit successfully. I want to make it clear that all of the plugins that I have presented so far either change the order of test cases or they skip over certain test cases, and this means if you have used the cache fixture and build order dependency into your test cases, you will run into problems with these plugins. That's it for today. Thank you very much for watching. If you enjoyed this video, please consider leaving a like and subscribing to my channel. Also, if you can think of any reasons why you would want to use the cache fixture directly inside of your tests, please leave a comment as well. I would love to hear about it. Thank you very much for watching, and bye bye.